Welcome to the second module, pseudocodes. Algorithm and pseudocode representation. What is meant by pseudocode? What is pseudo? Have you heard of this word pseudo? What does it mean? False. Pseudonym means false names. So basically, we use prefix pseudo for false names or false things. Pseudonym. Pseudonym means a false name. Pseudocode means a code that is not executable. A pseudocode is a code that is not executable. Okay. So in English, we commonly use the prefix pseudo to indicate something that is false or not true. So in this lecture, I will be explaining to you how to create pseudocodes, what are the essential features of good pseudocodes, and so on. So let me state a very famous quote that says, that gives you the difference between what is an algorithm and what is a pseudocode. An algorithm is a storyteller's script, while pseudocode is a builder's blueprint. Okay, so you are writing stories. So there is a small difference between an algorithm and a pseudocode. A pseudocode is a programmer's language. Is something which we are going to understand, which is going to help the programmer really create codes. So the primary difference between an algorithm and a pseudocode, both are the tools used for problem solving process. Okay. An algorithm is a step-by-step procedure that results in an output when necessary inputs are given. A pseudocode is a high-level representation of an algorithm. Pseudocode, we mix both the normal language and some of the syntax that is being used in the programming languages. And the objective of writing an algorithm and objective of writing a pseudocode are different. Okay. Pseudocode is a way of presenting an algorithm to a programmer so that the programmer is capable of writing the necessary codes. Algorithm develops the logic. The logic for writing codes. Pseudocodes is a better representation of a algorithm. So we have understood why we want a pseudocode, right? We'll define what is a pseudocode technically. Pseudocode is a simplified high-level description of an algorithm that combines the elements of natural language and programming syntax. So as such, in an algorithm, we do not use any kind of programming syntax. An algorithm is more explanatory and focuses more on creating of logic. Algorithm focuses in creating logic, while pseudocode is going to help us write the code as such, we are going to make it into small programmer readable language. That is what is pseudocode means. Okay, pseudocodes are designed for the programmers to write the programs. As such, pseudocodes are non-executable. You cannot run a pseudocode in any of these programming languages. But pseudocode can help us determine which kind of programming languages you would like to use. Okay. So this is the fundamental definition for a pseudocode. So let us write a pseudocode to evaluate an expression D is equal to A plus B into C. So here I am going to explain to you the difference between an algorithm and a pseudocode with an example. I've taken an expression A, D is equal to A into B, I'm sorry, A plus B into C. Okay. So this on the left side of your screen, you can see an algorithm written to solve this expression D is equal to A plus B into C. On the right side, you can see the pseudocode for the same. Okay. Algorithm, step-by-step approach towards solving this problem. First step, let me take my first step. So algorithm begins with start. After start, next step is to read the values of A, B and C. We are going to find out D given A, B and C. So A, B and C should be given as input to the code. Then what we'll do, the next step is to find B into C. Okay. After that, what we'll do, we'll store this B into C in a temporary variable and then add it up with A. So find the sum of A and this temporary B into C. Store the sum in D and print the value of D and stop the algorithm. So this is a step-by-step approach. This is called as algorithm. Now, when you compare this with the pseudocode on the right side, you can see that there are very few steps and really something that is more programmer friendly. The way that a programmer can easily write a code, programmer can decide on the programming languages which can be used, programmer can do a lot of, it's more a technical program. Here what we are doing, we are just giving start as usual, reading all the three inputs, finding out D directly, printing D and then stop. Here we don't need to have any temporary variable and so on because we understand that the programming language, whatever we are using, will have its own system of hierarchy of operations. Okay, so it will do the operations automatically, most of the programming languages. So you don't need to explicitly work on all these things. So this is a pseudocode. What are the qualities of a good pseudocode? It should be very clear, concise, and should be structured. Should have a very proper structure. A good pseudocode will have a good structure. Okay. Now, already we have an algorithm. Then we are going to write a program. Might be you are wondering, why do we need to write another one pseudocode? Am I right? Why do you think that we have to write a pseudocode? What are the reasons that you need a pseudocode in between your algorithm and your program? Any guesses from your side? Does it really make sense? Let's see. Let's see why we are very much interested in writing pseudocodes. So we need pseudocode because we need a prelude to our programs. We need to understand the entire problem very clearly. I told you that in problem solving, understanding the problem is extremely important. So pseudocode helps us to understand the problem, and it is not depending on any other kind of programming language. So you don't need to write the entire code and check whether it works. It is programming language independent, and anybody who knows no programming language can understand pseudocode. So it is very easy to understand a pseudocode. Second thing is that we know that algorithm makes out a logic, but a pseudocode really focuses on what the logic is and how this logic can be implemented. Okay, so pseudocode is required because we need to make the logic programmable. Okay, a logic is there, but how far it is programmable is something that is yet to be understood. So it focuses on logic. Third point, what you have written right now is that the pseudocodes are more legible. Okay, so we are having something called as constructs. We'll see what are constructs and English phrases that make, we have enough comments, and we have different methods with which we can make this more legible, understandable. I've given you 3 reasons why we need pseudocodes. The first reason was that it is very ease of understanding. Second one was focused on logic. Third one was more legible. The fourth one is that it is very consistent. Okay, so we have a standard way of representing this algorithm, and this consistent method helps us to create the programs that is necessary using this pseudocodes. And once we have written a pseudocode, it is very easy for us to translate this into a executable program. So the fifth advantage or fifth reason why you need a pseudocode is that the pseudocode can be easily translated into a program. The sixth point here, identification of flaws. Executing a program, maybe if you are doing it in an embedded system or a system which is using hardware or something else, maybe it is going to be more resource consuming. Sometimes executing the real code may be consuming you the resources. Okay, suppose I'll give you an example. You wanted to code in a microchip and you wanted to get it installed in a washing machine or some other thing. For example, of an embedded system. Writing a code directly into the chip may cost you the chip as a whole, right? So maybe there are situations where writing the code directly might consume resources. So if you have already written a pseudocode, it helps us to understand the mistakes or flaws in that, right? Whenever the general procedure of designing a product or an electronic system, what we do is that we create the product in a environment in your computers using different kinds of softwares. We simulate these things, we check whether this is working correctly or not, and then only make the original product. Similarly, when it comes to programming languages, we need a pseudocode to determine the errors in a program. Okay, and this could be something that is easily understood by everybody. What are the major differences between an algorithm and a pseudocode? So as we have already discussed, algorithm is a step-by-step approach, but pseudocode is a informal distribution in a programmer's language. Provides a precise structured method to solve problems, and this structured method is represented in a pseudocode in a readable and a language that is readable. Algorithm specifies the programming syntax or the mathematical notation for that. Pseudocode is a blend, is a path or is a way in between both this algorithm and the programming language. You have a programming language that is going to be completely executable. You have an algorithm that simply states the logic. So if you want to write a code, if you want to write a program, the language, what you need is you need an easily understandable, programmable syntax. It is a blend. You have a natural language also. You have, and these things are understood by everybody very clearly. Even if you are not a programmer, you can understand it. That's the advantage of pseudocode. Okay, algorithm is a defining of logic, defining of all these steps one by one. Okay, so algorithm focuses on the technical correctness, maybe how far it is correct, but pseudocode is something that is going to read the, that's going to make the programmer do his job very easily. Understood? So suppose if a question is asked for you in your exams, differentiate between pseudocodes and algorithms. Can you write it? Constructs of a pseudocode. So constructs of a pseudocode. What do you mean by constructs? Any idea? Can anybody tell me what do you understand by the word constructs? Constructs, you can consider it to be the features or the steps that is going to create a pseudocode. The first thing is that we need a structured programming approach. A structured programming approach will improve the readability of the pseudocode by ensuring that the execution sequence follows the order in which the code is written. Okay, structured programming means which should come first. What is your priority? What is the first step? What is the second step? And so on. There should be a proper structure. What do you mean by structure? How it looks like? So a structured programming language should have a proper order, a proper look. Okay? Sequence. Sequence means you cannot interchange things. What should come first should come first. What should come second should come second. So it should be in a sequence. Decision making. We'll see an example of decision making construct in the next slide. So here we need to decide which is right or not. Okay, I told you about an example problem in the first class. Whether you want to go to a movie or not, you need to make a decision. If that is your problem, you need to make a decision. Tomorrow you are having exams, and today a new movie is released. How many of you prefer to go for movie than to sit and study at home? Okay, nice. So you need to make a decision whether exam is important for you or movie is important for you. This is all about decision making. And now we'll see. We'll write a pseudocode to see whether the student who had gone for the movie passed or failed. Right? We'll write a pseudocode to check whether a student has passed or failed, considering the minimum marks to pass an exam is 50. You can observe that a pseudocode is more programmable or is more easily understood by a programmer. Here you can see that you have different blocks like you have it in Python. We have seen 1 or 2 lab sessions in Python. So here what we are doing is that we are starting the code, we are getting the marks, and then now we are checking whether mark is greater than or equal to 50. If the mark is greater than or equal to 50, the output is the student has passed. Otherwise, the student has failed. And this and if is a block, and this block we are closing this block. And then you are concluding your program. You are coming to the end of a program, or you are coming to the end of a pseudocode. When you observe this, you can see that this has more correlation with the programs that you are going to write in your lab sessions, or this is going to be something that you are going to execute. So if statement is a construct, and you need a decision making or a selection point where you need to select this is correct or this is not correct, and so on. Okay, is that okay? Next construct, iterating through a series of numbers or a group of numbers or a group of data, whatever you wanted to traverse from the beginning to end. This is called as iteration. Iteration means you take the first element and go to the last element. Next construct, input and output, or input or output, whatever you have. You need a data that you're going to collect from the user or the programmer, whatever it is. And then you're going to perform some operations and give its output. Initialization and assignment. See, every good program uses less number of variables or uses minimum memory space. So you can assign variables in such a way that minimum or the least memory is being used. So initialization, and for the last example where b is equal to, I'll show you an example with initialization and assignment in the coming slides. But now, for the time being, you can understand that giving the initial value to 0 or something like that is initialization, and assignment of value from one to the other is assignment. Okay. So next is a very important construct called as case construct, or in other words, those who are familiar with other programming languages can know what is a switch statement. In Python, we don't have any kind of case statements, but in Java you have it, or many other programming languages we have it. So is a conditional statement which executes a set of programs based on different kinds of conditions. For example, if you have only one condition, or you can have if, elif, else if, else, and so on. But the number of conditions can be less. But in case construct, you can have more number of conditions. Or if you have more number of conditions, it is better to construct the pseudocode using case rather than if. Next, we'll see an example using case construct. So here you are assigning grades to the students who have scored marks in an examination. If this mark is more than 90 and less than 100, that will be the maximum mark, we are assigning grade A to the student. 80 to 89 grade B, 70 to 79 grade C, 50 to 59 grade E, and below 50 you are declaring that the student has failed. So this is an example of case construct where you have so many conditions, and for each conditions you have a particular statement that, or one or more number of statements that need to be executed. So next is an algorithm to convert the temperature from degrees Celsius to Fahrenheit. After this, after you have written the algorithm, I'll show you the pseudocode for the same, so that you can understand how pseudocode differs from algorithm. Okay, so all of you may please write down the algorithm. Now when you consider the pseudocode is only a few statements. Okay, you can see that it is going to, you can use begin or end or start and end, whatever you like. It is not an error. You are inputting C, you are setting the value of F, and then what you are doing is that you are printing the temperature. That's it. So this is more programmable or programmer friendly. Right? So next is an assignment. Write an algorithm, and sorry, there is an and here. It's a printing mistake. And a pseudocode for the expression y is equal to x square minus 4. Write an algorithm and a pseudocode for the expression y is equal to x square minus 4. So with this we have come to the conclusion of a lecture on pseudocodes.